Let's see how to carry out welding operations in CYPE Connect to resolve a connection between beams. Starting from a previously created node, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. In the Connection pop-up window in the Model tab, we must specify the operations needed to define the connection. In this example, the sections of the secondary beams B2 and B3, which run perpendicular to the main beam B1, have been adjusted and trimmed in advance. Also, a plate attached to the top flange of beam B1 has been added. Now we are going to enter the necessary welds between the sections of the beams and between the plate and the beams. To do this, we click on the Weld option in the top toolbar. First, let's see how to add the weld of the bottom flanges of a secondary beam to the web of the main beam. To do this, in the top part of the central panel, we select the element to be welded from those available, which can be a section or a plate. We select Section, and in the drop-down menus on the right, beam B2 and the bottom flange that we wish to weld to another section, which is beam B1, and more specifically to its web. The parameters of the weld are defined below. In junction type, we choose whether it is a fillet or a lap weld. In this case, we select fillet weld. In the first drop-down menu, we have several possibilities for defining the position of the weld. On the left side, on the right side, or on both sides, as is our case. In the second drop-down menu, we choose if the welds are fillet welds defined by throat thickness or by side thickness, or by double bevel butt welds. In the third drop-down menu, we set the shape of the weld surface, whether it is not defined, flat, concave, convex, or with toes blended smoothly. In the fourth drop-down menu, we indicate the place of execution, either on site or at a workshop. The program has a help function at the top right of this section, where we can find more information about these options. In our case, we define welds by the throat thickness, with a dimension of 4 mm. We can also indicate the parameters of the electrode, including its reference and the resistance of the filler metal. Finally, we specify whether the welds have an initial or final displacement. By default, the program places the weld on the flat part of the flange, interrupting the weld at the chord radius of the section. To apply this operation to the other beam, we select the operation and use the copy option, available at the top of the table on the left. In this new operation, in the Elements section, we select beam B3 without changing the rest of the parameters. We make a new copy of the previous operation to apply it in this case to section B3, and more specifically to its web. This defines the weld of the web of the secondary beam, which by default takes its full length. We can adjust the length of the weld by setting an initial and final displacement of 20 mm in both cases. We copy this operation again to apply it to the web of section B2. This way, we complete the welds between the sections of the beams. Now let's see how to define the welds between the plate and the beams. By clicking on Weld again, under Element we choose Plate, selecting the only plate entered in the model from the drop-down menu on the right. First of all, we wish to weld to section B1, and more specifically to the top flange. Within the parameters of the weld, we define, in this case, that the junction type is lap. Again, here we define a fillet weld by the throat thickness with a dimension equal to 4 mm. For lap welds, the location option appears, which can be on all edges or on a given edge. In the latter, we must indicate the edge number, which can be consulted in the view of the connection. In our case, we use the location of a weld on all edges. To apply the weld between the plate and the secondary beams, we copy the operation and apply the weld to section B2, without changing the rest of the parameters. Finally, we copy the operation again and select section B3 in this case, once again without changing the rest of the parameters. From here, once the model is finished, we can continue with our work by opening the Analysis tab in order to analyse the connection.